also post any questions. As I was telling, the session is a bit packed, but we'll try to answer some of them. And as for the rest, since we will have the list, we can also try to follow up offline. Okay, so these are all the panelists. So we have, this is myself, I'm representing the InterTwin project. We have Gabriela from BioDT project, Ignacio Blanquer from the DTGO project, Arne Ver from Iliad, Aquainfra, and part of Edito, Model Lab, and Edito, the digital twin of the ocean. And we will have a video from Thomas Guinen. So, a bit of introduction. So this session is trying to capture like the whole potential that it's starting to bring to the scientific world or the scientific community, all these digital twin ideas that has been developed like over the last 10, 15 years in the industrial sector. And they are increasingly being leveraged by scientists. So this is an opportunity to bring it to the EOS Forum and to discuss what are the challenges and what are the opportunities that this is brought. And we have brought the big part of digital twin developers or digital twin developing communities. So maybe a bit of introduction. 2 years ago, when I was presenting InterTwin, the first question I did is like, what are digital twins? And people were not able to have like a common answer. And so there are different views. We've been using like the standard definition from the Digital Twin Consortium, like as a virtual representation of the physical object processor system that can be sustained with information that is derived from different data sources and that gets updated in real time. So we will get permanent new data that it's enabling the model to evolve. And that's why the name is digital twin. There are many views and many different visions, and that's also part of the work that we are doing together. And yeah, it's part of the discussion point. Last year, it was the first time we came together, like different digital twin initiatives, like under the conference session. So it was led by BioDT that we have here. And ever since, we have seen an increasing number of initiatives that we have started cooperating. And I am very happy that to bring here like one of the largest set of projects that we have ever had in such discussions. So I'm really glad, and also for the responsible people we have here. And yeah, we are collaborating, started to collaborate into this cross-digital twin working group that we are trying to develop, like some joint glossary of common terms, and we are trying to check all the synergies. We started also collaborating together with Iliad people on standard for the digital twin of the Earth. And well, there are many ongoing initiatives. So this brings to the introduction. This session, we will have the different presentations of the projects and the panel the video of Destiny as one of the first main users of main developers of digital twin, or one of the first operational level digital twin that has been planned by the European Union. And then we will have the panel discussion. So, and I will be representing the first project. So then I change my hat to the InterTwin Innovation Manager. By the way, my name is Xavier Salazar, Innovation Manager at the EGI Foundation, the institution that is coordinating the InterTwin Consortium. It's more than 30 participants, quite big, along the whole Europe, and it's comprising providers, like technology providers, infrastructure providers, and then community representatives that are able to deliver different digital twin use cases. So what are we actually doing? So we are aiming to develop a digital twin engine, which means a layer before that, a middle layer that is aiming to enable digital twin application developers to facilitate their development. So that they can be connected to infrastructure and with the resources and the capabilities that they will need, and to facilitate the whole digital twin process that is needed. We are developing everything under open source and open standards so that we can maximize the reusability. And it's piloted by different use cases that are ranging from interdisciplinary areas. So we have climate related and environmental related use cases. So there are several digital twins developed on these aspects. And some on high energy physics, radio astronomy, gravitational waves, and more into deep science. And so how are we doing this? So we have created a sort of blueprint architecture that enables like the whole modular system that we are developing. Okay, so the main or one of the key aspects of this blueprint picture is the fact that so who are our users? On the one side, our main user. So we see our main user as the developer of digital twin applications. So it would not be like the end user of the digital twin, but the communities that are developing those. So that we will facilitate the work for them, okay? And obviously the operators as well, the infrastructure operators that want to get like digital twin applications running on their sites, okay? So these are two layers that are often like unseen by the communities and by the users themselves, but are completely necessary. And if you are developing a digital twin, you need to have them, and you want to have them as easy as possible. From an architectural point of view, so we try to make it as modular as possible because not all the applications need the same type of operations behind and the same type of, they don't use the same type of data, they don't use the same type of resources, compute resources. So we have different modules that can be plugged and can be used depending on the application itself. And obviously, we provide the support for bringing them together and to letting the developers understand like which are the best components. Okay, on the workflow side as well, some of the noteworthy to mention, or one of the main work that we are doing as well is on the so that we are also developing like an AI module, so modules that enable to support AI workloads and AI training, so that this can also be incorporated into the different applications that we develop. And yeah, if you want to learn more, so we have the second version of the blueprint architecture that it's on Zenodo, and we are about to publish like the final version. So be tuned, because very soon we will have the final version, so you can also learn more about. That's a bit the timeline. So we are in the last year of the project. So we will appreciate all your feedback and all the questions, because now is the moment that we can really incorporate them. There has been a first release, so you can also try out and test, like see what's there. And there will be a second release and a final release expected. And yeah, so why we are here? Because we want to integrate and we want to see how interesting can be for EOSC and can be using EOSC to deploy digital twins. And this was one of the objectives of the project at the initial plan we had. The whole landscape has been evolving over the time, so we had the plan to integrate our systems into the EOSC core via the same AII system, onboard the higher TRL components and services into the EOSC portal, and we would get like the access from the EOSC. This has been evolving. Okay, so now it's becoming this federation of nodes. So we are at the moment that we are discussing. Okay, and how to do it. There are several possibilities that maybe we can leave it later for the discussion. Okay, and thank you. Questions later for the panel. And next, BioDT.
Hello. Do I change the slides also? Yeah. Okay. Okay, dear audience, my name is Gabriela Zucchini. I have a background in ecology, biology, and vegetation modeling, and I'm currently the coordinator of BioDT, the Biodiversity Digital Twins project, which means that we are advancing modeling, simulation, and prediction capabilities. And at CSC, the IT Center for Science in Finland. So thank you for your presentation. You made my life easier because I'm now talking about digital twins again. So you already defined what a digital twin is. We also had this discussion in the beginning of our project. What is a digital twin? And now we are modeling biodiversity. So bringing the concept of biodiversity, of digital twins to biodiversity, which is extremely challenging, sorry. But it's interesting to say that behind the launch of, behind the launch, here is the point, of a digital twin, we have all this work done on the background, and that's extremely important, and also in the context of EOSC, it's also very interesting to discuss. So in biodiversity digital twins, in the BioDT project, we have several study cases that I'm not going to discuss them in depth today, but we have 10 planned prototype digital twins that range from a really wide different topics on biodiversity dynamics, pollinators, disease outbreaks, invasive species, etc., etc. So all them we are aiming to reach the prototype level. And since the start of the project, we had this wide range of challenges. So we, on purpose, tried to cover the different levels of maturity of different biodiversity topics, different levels of achievements of fairness, for example, in the data, in the background, to really put the digital twins concept into testing. So, but I will tell, so there is all this work done towards a prototype digital twin that is interesting for the EOSC community, but I will also show what is a prototype digital twins. So we had now, finally, after 2 years of the project, launched the first 2 PDTs, that like we say, prototype digital twins. And these 2 PDTs are one on cultural ecosystem services and one on honeybee modeling. And we are planning by the end of the project to have more, and they are really coming in the next months. So what kind of questions a prototype digital twin can answer? So just one example, because the time is short, but I think it's interesting to see something more concrete than the plans. You can ask, for example, what are the best locations and treatments to optimize honey production? So if you are a beekeeper, or if you are a land use planner, or if you are in the Ministry of Agriculture, you can use this kind of tool to plan your production. How? This is already out, so there is here the link. For example, in this PDT, you have a map. We are in the in Germany, so you can ping, the user can ping different locations of Germany and define several parameters. For example, the size of your bee colony, the kind of treatment you want to use for the parasites, and then you run the simulation. The simulation is running on Lumi. I will tell what Lumi is in a second. I guess some of you already know. And after running this simulation, based on the crops that are on the surrounding, on the environmental conditions, soil conditions that are around your area, it will simulate how the bee population changes along time, and here it would be the honey production, how honey production can change. So very clear tool. You can choose different areas, see how your beehive would behave, and plan better locations for your production. So just to conclude, that was just one example. I usually start with these slides because it defines what is digital twin is. But here, I believe that shows that by nature, the concept of digital twins in biodiversity and elsewhere, by definition, because it's a concept that requires a lot of data, quite often complex modeling, and then the development of an interface, it's by nature a concept that fosters collaboration. You require these data research infrastructures to collaborate. These are the ones that are in BioDT project, that's why they are here. You also require a very good and usually a high-performance computing, I'm good in time? High-performance computing infrastructure to collaborate, and then developing user interface. So in BioDT, we have the Lumi HPC, that is the fastest supercomputer of Europe and third in the world, that is hosted at CSC. Just to give an idea, this is the equivalent of 1.5 million laptops working at the same time. And with that, I think I wanted to just conclude. These are the institutions that are part of the BioDT, and is the community that we are building. Thank you.
So next, DTGO.
So thank you so much for the invitation. I'm trying to make a short presentation on another project which is called DTGEO, whose name is Digital Twin for Geophysical Extremes. I'm more involved in the technological part, not in the part of the development of the simulator or the specific use cases, but I'll try to give an overview of the presentation, of the whole achievements. So the DTGEO has 4 general objectives. First, to deploy a pre-operational prototype of a digital twin on geophysical extremes. These geophysical extremes are well described on the second objectives, which is the implementation and development of 12 digital twin components for simulation and other type of analysis of hazardous phenomena for volcanoes, tsunamis, earthquakes, and other problems related with the activity of humans. So you have these 12 different types of digital twin components described on the list. Also, we have as a third objective to provide a flexible framework for the fair validation, both of the data object and also the software, with a very extensive work on the software quality. And finally, to verify with 13 site demonstrators. So let me go in detail with more detail to the part related to the architecture. So we have 3 blocks that can be described. So from the definition, we have a set of components that describe the data, describe the software, describe the components that run the software, and the workflows that also are composed by the different components. Everything is publicly available on a set of repositories that are indexed through the GitLab of DTGEO. So these components describe the execution environment also. So these components can be deployed using infrastructure as code specifications, so it can be deployed on different types of platforms like HPC resources or cloud resources. This is done through two main components. One is Infrastructure Manager, which is one of the components that take these Tosca blueprints that define the topology of the application and deploy it on the cloud. You have also recall that Tosca was mentioned this morning in the EOSC EU node. This is the same component that is used in the EOSC EU node. And also the containers are built on the fly or adapted to different types of platforms using a specific and a standard specification. Also, we have an orchestrator that facilitates the scheduling of the task of these workflows on HPC and cloud resources. So tries to exploit the data parallelism directly without having the programmer to explicitly define it, and everything accessing the data through the data as a service components. So this blueprint architecture is also well related to several EOSC aims. So let me first say that we, in the project is deeply engaged with the compliance to the FAIR principle and the compliance to the EOSC vision. We have a public registry of the assets. We have assessment of the FAIR principles to the FAIR EVA, which is a tool that assesses the different metrics that are defined by RDA with respect to the FAIR principles. Also, we have the adoption of the DCAT application profile schema for EPOS, and it has also been extended for DTGeo-specific metadata. The use of a de facto standard specification for the digital twin, containers, SPAC specification, Tosca blueprints, JIT repositories. We have software quality assessment through one component developed in EOSC Synergy project that ensures that the software has, reached a minimal level of quality defined by a set of principles, the integration with existing infrastructure, and thinking on reusability, also providing results in a workflow hub registry using the rock rate specification. And that's all from my sides.
Arne?
Thank you. My name is Arne Berre, and I will talk about digital twins in the context of the marine environment and on environmental twins, starting also with the context of Destination Earth. Let me see here. This was the wrong way. That's the right way, I think. So this is the reference architecture of Destination Earth. Thomas will talk about two twins here, the climate change adaptation and the extreme weather twins. You see that to the right. You see the kind of reference principle of having core services, data lake, and digital twins running on digital twin engines. This picture also shows the links to data spaces that has been discussed here. We have heard about the health data space, we have the Green Deal data space, and others. There are 3 new twins coming under Destination Earth now that are awarded and are under contract negotiation. And then there are other twins, as we have heard about, including digital twins of the ocean, which I will talk about. It's also a part of the UN Ocean Decade until 2030 from the international context, and the DITO, the digital twin of the ocean, and a number of European initiatives that you see here to the right is contributing to this. From the European perspective, in particular, the European digital twin of the ocean is a focus point, supported primarily by 2 projects, a procurement and project, a DITO Infra and a DITO Model Lab. And here you see on this picture again, these components of the data going into data lake, and then the digital twin being supported by a digital twin engine. The technical architecture here is following the same structure. So here's the kind of structure of, this is to be read from the right to the left. We have data coming into the data lake. Then you have various models supported by the engine, and there are services that are interacting with users. Both Destination Earth and DITO is using stack catalogs, spatiotemporal asset catalog, which is particularly suitable for spatiotemporal data in raster coverage form. And coming from Earth observation, this is a suitable technology. Also, other data representations are relevant. Vector graphics needs additional representation, so we're also discussing that in the project. What are the kind of data representation that is suitable for environmental digital twins? The project that I'm particularly working on is Iliad, which is one of the Green Deal projects that was started at the beginning of Horizon 2020. And here we have a number of digital twins, around 12 different areas I think we see here, such as wind farms, ocean energy, coastal sediment handling, plastic pollution, fishery, aquaculture. We have more than 20 different areas, and in details we see that here. Of these we have 8 that are particularly reference areas, and then we have a lot of other activities that will be replicating from this. And then we use various technologies along this data cycle from data acquisition to data models and representation and analytics and visualization. The architecture is illustrated here with a focus on multiple twins with interoperability between, and a digital twin life cycle going from digital twin data acquisition to the representation to analytic models, and then to visualization and control and interaction. To the left we see data spaces as well as sensors and observation. Note EOSC as a data space is one area. Particularly in the marine community, we have EMODNet and SeaDataNet, and then from the satellites, Copernicus and Copernicus Marine Services, but also additional data such as the Green Deal data space, including citizen science data, biodiversity data, socio-ecological data. So there's a lot of sources of data to draw from and to bring into a data lake or a set of data lakes. EDITO has the data lake and engine as you saw. We also have multiple data lakes, so each digital twin needs a data lake to bring data close to the processing so that you have the subset of data you need extracted and also then obviously harmonized from a semantic interoperability perspective to be combined and used in the models and for the analytics and for the visualization and control and interaction. In Iliad, we also have a marketplace to make all of these components and services available, and also an activity on best practices on digital twins. If you relate this to the EDITO infra architecture, you see that EDITO is currently not so focused on the data spaces. That will eventually probably come there. Obviously, EMODNet and CMEMS are large data spaces to some extent. That goes in here. But it's important now to align these components and look at various interoperability points. We heard about BioDT. There is a project called DTO BioFlow, which is also having BioDT partners and instantiated in the digital twin of the ocean context. So here's the DTO architecture, but you see now that we bring in biodiversity data here from the right that goes into the representation forms that includes ARCO formats, analysis-ready, cloud-optimized data into the data lake, and various suitable representations. Again, if we map this into Destination Earth, and we will hear Thomas talking about Destination Earth, and in particular the twins shortly, we see that there are a lot of harmonizations that are relevant and in place, but there are also differences that we need to discuss with respect to interoperability. Final project to present is Aqua Infra, which is indeed an EOS project, sister project of Blue Cloud. Similar architecture, this is like bottom to top, getting the data into data spaces and then into data lake, talking about value chain from bronze, silver to gold data, from the raw data to analysis-ready cloud-optimized data, and to bring it into workflow settings with virtual research environment. This project is in particular related to the EOSC evolution, and we see the recent EOSC node architecture and the resource hub and the core services here. So the question is how to take advantage and to place this here. Similarly also to the NVRI community. And to the right on this picture, we have the various digital twin projects that I just mentioned. So obviously how to get this to interoperate and work together is one of the things we would like to now discuss further in this community. Thank you.
Okay, so it's time for the video.
Good afternoon, my name is Thomas Jean and I'm the Technology Partnership of Destination Earth working for ESNWF. In the next slide I would like to quickly give you an overview of the Destination Earth program. So Destination Earth is an initiative that wants to develop a digital twin of the Earth system. Initially we are focusing on two main digital twins, one on climate change adaptation and the other one on extreme events. So Destination Earth is an initiative, as I mentioned before, to develop these digital twins of the Earth with the focus on these two particular topics initially. It's in close collaboration and strategic partnership with EuroHPC, where the large-scale simulations are being run that underlie these digital twins. There's the ambition to develop, establish bespoke cutting-edge simulation capabilities, and at the same time also provide a system where Earth system information will be made available at scales where the impact of extreme events and climate change are being felt. And as a last objective, we would also like to foster and innovate a thriving AI-enabled digital ecosystem as part of Destination Earth. The two main digital twins, as I mentioned, are on climate change adaptation, with a main goal to support policymakers for adaptation strategies and operates on multi-decadal timescales. And the other one is on weather-induced extreme weather events. That one is targeted on rapid response to extremes and has timescales of just a few days. The climate digital twin, as you can see here, will be operating at much higher resolutions than is currently available in the context of IPCC. We have the ambition to run these climate scenarios at kilometer scale globally, and that will allow us to zoom in on events that are relevant at a regional scale. The first major outcome of Destination Earth is as well that it will be first ever projection between 2020 and 2040 of such a high resolution climate simulation. The second digital twin, let me first give a few more details on the climate digital twin. So as you can see here, it actually at the back end it has several models, two IFS based, one icon based, that are basically outputting their data into a generic format that then streams this data to downstream applications that will be able to analyze the data as it is being produced. We have a monitoring and evaluation framework that taps into this data stream that can do online real-time evaluation of the quality of the simulation, but also on the outcomes while the model is being produced. And these models are then also the outcome of these models are also made available for downstream applications on the different impact sectors like the energy sector as an example. The other digital twin that we are developing is the one for extreme weather events, and it basically provides a magnifying glass on extreme events. So we run a global weather model that is able to detect extreme events, and as soon as an extreme event is being detected, it can trigger automatically, or you have also the opportunity to manually trigger those, to trigger manual or to trigger regional models that will zoom in on the area where this extreme event will happen, and allow to analyze in great detail what these extreme weather events will result in. Also here, quickly the setup. So we have this global digital twin running on a daily basis, forecasting the weather 4 days ahead, runs at a kilometer scale resolution globally, and when an extreme event is detected, it will trigger regional models that will run at a 100-meter resolution to capture and resolve these extreme events. And that information will then be made available to downstream applications and models for the impact sectors that we mentioned before as well in the context of the climate digital twin. And that was all I wanted to say about Destination Earth in this very short, brief overview. Thank you very much for your attention.
Okay, so that was the video. We would like to get the panel discussion. Okay, so we have set up the scene and with all the presentations. So now it's time to further deepen on why we are here. Okay, so I would like to open the questions, like get a bit more detail on how are you planning to integrate the result into the whole EOSC environment, and maybe we can start with the projects like with DT BioDT and DT Geo, and then so.
Whatever you want.
Hello. Okay. Thanks, Javier. We believe that the results from BioDT, since BioDT is a thematic project and it has a life cycle, it's a European Commission project, would be interesting to the data services, the data stream, the modeling, the HPC capabilities, they are all relevant for the EOSC community, and especially could be in a thematic node, for example, not in the EU node, but in a thematic node. Then the question is how, and that's a bit open at the moment because we don't really know how the thematic nodes will look like at the moment. But we are hoping to have this progressing and this discussion to continue towards this implementation, and also thinking in the afterlife of BioDT and in the connection with other EU initiatives.
Following the comments of Gabriela, there are two directions, I think. One is, as you were mentioning, about consolidating an EOS node, or because there's the possibility of providing the service also to an existing EOS node. So that's something that will come as things are getting clear. But what is, I believe, in our side more clear is that there are services already that we can, be at least compliant to. The EOS EU node has a blueprint architecture in which we can find some possibilities of interoperability that we can define at the level of the AI, at the level of the fair principle validation. There's also a resource hub there in which, advertising or advertising is a bad word, but registering the services, the data and the software that is available at DTG, for example, will be a good point for ensuring that those resources are discoverable and findable by the community, even they are not aware that DTGO is there. So at least this will be one path that we can follow easily. Meanwhile, all this concept of the federation is getting clearer.
Okay, and since we have a more well-established ecosystem related to the digital twinning of the ocean, so maybe we can evolve this question, like how are you planning to align the activities that are linked to the digital twin of the ocean with the EOSC evolution?
Yeah, so obviously it should be a great opportunity for synergies. I think we are interested in see how the nodes will evolve from national nodes and thematic nodes. There are already initiatives in EOS, such as the ENRI community and Fair East and others that are dealing with environmental data and models. So it's a natural evolution to bring the digital twin context into that. So that would be a natural home. And obviously we have the national data of lower or high resolution that is also relevant. So hopefully we'll find synergies also with that. Particularly in Norway, we have a lot of high-resolution data in our national infrastructures. Partially, it goes through already established aggregators such as CDataNet and eModNet. So there is already a mature community that we can build upon there. And then hopefully also harmonize the architecture so we can have common components across various of the digital twins of the Earth, not only of the ocean, because we see a lot of commonalities here.
Okay. And so we were also bringing all these initiatives together. So a fast question to all of you, like how to foster this collaboration. So how can the interoperability between the different initiatives be supported from your point of view between each other and as well between, as it has been explained, well, with Destiny, with data spaces, and with all these different ecosystem players.
Yeah, one point to mention is that we have a parallel session now on interoperability. So obviously this is an important topic, and I think we can speak about both technical, semantic, organizational, and legal interoperability. I need to take all of this into account. But I think this community is well prepared with a discussion on ontologies and knowledge graph on the semantics, which will be domain specific, but there are also cross areas for environmental twins. So I think there's a good foundation for that, and I'm happy to see that we have so many projects that are also eager to discuss interoperability among them. So there should be a good opportunity for synergies on this.
Okay.
Yeah, thanks. And if I can add, in BioDT in particular, we have the challenge of working with biodiversity data, which is extremely heterogeneous on how it's collected and the level of matureness of fairness. So a huge part of the work done in BioDT so far has been working on improving the data fairness of biodiversity data. So that is, by nature, something extremely important for the EOSC community and for the future of biodiversity studies, research, and development, and for EOSC too. And also, we have been improving interoperability in that direction, and I think the next step is also to evaluate like the AI readiness of the biodiversity data. So I would say that especially working with the research infrastructures, for example, in the context of biodiversity data, we had some key partners are the Global Biodiversity Information Facility, GBIF, if you, some of you know, probably know, LifeWatch ERIC, for example, and ELTER, the Integrated European Long-Term Ecosystem Critical Zone and Socio-Ecological Research. All these partners are critical for biodiversity Digital Twins project, and will certainly be very relevant in the EOSC next steps.
And with DTO Bioflow and other sister project, there is a good synergy in place already on that for the marine and also the freshwater biodiversity.
And if I can add from the technological point of view and from the ICT point of view, I'm glad to see that some of the approaches also are considering similar interoperability paths with the deployment of the digital twins on the infrastructure. I think that having clear APIs, clear description of the components will also facilitate sharing the components, sharing the workflows, or even composing workflows across different entities. That's something that can be technologically achieved.
Okay, thank you. So I would like to give the voice to the people attending as well, because you might have questions or concerns. Or okay, so.
Hi, Dick Schaap from Maris. I'm also a technical coordinator for Blue Cloud. Now it's very nice to hear, let's say, your progress in fact in such a short time, because one of the things that I'm wondering is, because you need data, and I know all about data, I all know about technology, but you also need models. And did you, and what we say with DTOs, I say we want to do what-if models. If this happens, And you need a lot of knowledge to be able to make that model. So how did you achieve that in such a short time? I don't understand that, how you did that.
So this question is directly for me, for biodiversity.
No, for all of you, because you are showing us like you have already a ready-made system. And for the destination Earth, for Thomas, I understand, because they have these models. So he showed, let's say, how they improve the models using other technology and supercomputing. But you are doing what-if questions. And to my knowledge, you need much more knowledge to be able to do that.
If I can start, as I mentioned in my presentation, from the beginning of the project, we chose to have different levels of maturity. And I mentioned the data, but also in terms of the models. So the example I gave about the bee dynamics, it was based on a model that builds on 20 years of research. So it was one of the most mature models. It was, let's say, already done. There was a lot of work in terms of upscaling to HPC, to high-performance computing. That was an important step that in the Biodiversity Digital Twin project we managed to support researchers to adapt their models to HPC. But yeah, that's true that as expected, not all the models were done. And some are still being developed, but the ones that moved faster were because it was already in a level of maturity that we didn't have that much work to do. It was a lot of work, but starting from a good point, yes.
If I can add, I mean, I just skip one slide due to the time that shows all the previous, the background of the development of DDG. There were a lot of previous systems already available and validated. So, I mean, what it is focusing DDG is more on the part on consolidating and standardizing the way of deploying. So totally agree with your point.
Yeah, it's a good point that we need the model competence from the various domains involved. Obviously, we heard it from biodiversity. We also have the various industrial cases for energy and for fishery and for, say, pollution and microplastic. We can take advantage of the meta-ocean models for drift models. But there are also new projects that have started already on socioeconomic models for digital twins on the ocean in particular, for a new project. So that deals with socioeconomics, so the impact of industrial activities or interaction with the ocean. And for that, there are people with, say, socioeconomic ecology background. So it's really a cross area of different communities that are being brought together in these already funded projects. And we hope to take advantage of that.
Okay, so we have another question.
Yeah, thank you. Fotis Karagiannis from Athena Research Center and Innovact. So in most of your presentation, I saw resources being used from EuroHPC or HPC. So I guess there needs to be a bridge between EOSC and EuroHPC. There was a point from Gustav Kalbe this morning. He's the director of Directorate C in DG Connect, but I missed the exact point. So I don't know, maybe Ignacio, you also have the hat of the EOSC Association. Maybe you know of the discussions between EOSC and the EuroHPC, whether there is any progress, or maybe you heard what the exact point from Gustav was. So I think, but the point is that there needs to be a bridge between EuroHPC and EOSC.
Okay, take it into two directions, and the part of DDG and the part of the, with respect to the message of Gustav this morning, I mean, in all the presentation of the EOSC, you know, there was a mentioning on the inclusion of EuroHPC, but I'm not aware of any concrete action on this direction, right? So maybe this will change in the future. I think it was nice also to see that all of us, we are considering HPC resources due to the heavy part. But it will be important to understand that, one thing is one model that is on an HPC system that has an agreement on using these resources and how this also is given to the community, because in most of these HPC resources, you have to have a project in order to access the resources and all the like. So in these cases, there are pre-agreements for running the simulations, but it's important to understand this scenario. And maybe this scenario of credits that was mentioned this morning can also be extended of external provider of resources, could be also cloud providers, it could be EGI, for example, providing additional resources that can be gathered, linked to for the deployment. It's good to see that all the deployment are quite agnostic in a sense.
I think it's an important point. Destination Earth has actually put a lot of resources into that and have extended architecture going from the cloud to the HPC with the bridge architecture for that. That is fairly adapted for HPC. So this is a starting point that is already operational. Obviously, BioDT with CSC is running Lumi and is doing that with using the Lex architecture from previous high-performance computing. So there are various technologies that are being deployed and experimented with. So it's a good starting point, I think, with the digital twins and HPC, because it's already being considered and worked on, and we can learn from that and bring it further into the EOS context also.
Yeah, so it's a very interesting question, because digital twins are a very nice example, because they are using, or they have the need of HPC capabilities, but they also have the need of real-time update. They have the need of having some operations. So it's a really good example for this, and it can be like a good way to prototype like all these connections that are needed. So.
And with the new AI factories that will start up next year, which is also related to the HPC community, as we'll discuss, I guess, tomorrow morning, we will also have a good foundation for that, which will be important.
Okay, so, and yeah, I would also like to give some voice to the Slido. So, I will take the first one because it's the most voted and the one that was posted first. And I think it's also covering a very interesting point. So what is the interest for business? And it's as an example buyer, but it could be like any further business or industrial involvement to participate in digital twin projects. And I think that's also opening a very big question for the DT projects, so whoever.
Yeah, I think it's interesting to observe that the digital twin activities is really emerging from industry, from manufacturing process industry, but now with organizations like the Digital Twin Consortium is very industry driven, because obviously in a business context to have access to real-time information and to be able to do actions on various timescales is important. We see from these 20 plus pilot applications that we have in Iliad, a lot of things are related to industrial interest, being fishery, being oil and gas exploration, being energy, wind farms. So it certainly is a lot of interest. And I think maybe a point of digital twin which could make is that the asset-oriented digital twin that we have from the industry can now be complemented also with the environmental digital twins, which are the context in which the industrial assets live. And it becomes quite important both to take advantage of the environment in a sustainable way and to understand the impact of environment to combine this. And thus it becomes even more important to do this for the future, I think.
Mm-hmm.
Yeah, I agree, and perhaps just putting a bit of a historical context, actually the concept of digital twin comes from the industry, comes from business, that it was developed first there, and then we try to adapt for the biodiversity context. And one of the challenges is when you're building a digital twin of an airplane or a car, each component, each part is known and developed by humans. And when you go to biodiversity, we are talking about evolutionary processes and processes we don't understand how they work. So if the question is specifically how biodiversity digital twins can be interesting for business or industries, then I think that example of the honeybee could fit, that can answer, I think, more specific questions for different target users. We also have in BioDT, as I said, I can say, give all the examples, but we have one on forest management in which the user will be able to try different cycles of cutting the pine and check how it affects carbon and release, and also production of wood. We have one with grasslands, so how it affects biodiversity of the grasslands, but also the yield of grasslands. So these are kind of specific examples for targeted users. Thanks.
I mean, I think that my colleagues have left it very clear.
Okay, so we have 3 minutes, so we will not have time to deliver all the questions, and but noteworthy to say we will try to answer them offline afterwards, so we will collect them because I can see that they can be relevant and meaningful, and even challenging, some of them, and yeah, so we can get
Now, if you go, let's say, the Commission, they have a nice page on digital twins of the ocean, and they say it should be all inclusive. It means that every user should be able to use it, from citizen to policymaker. And what I've seen so far is that we have a lot of, let's call it virtual research environments and Python notebooks, and I don't think that's for the citizen or for the policymaker. So I was wondering, let's say, if you look at your interfaces, are you already at the level that, let's call it, the average person can use it? Or is it still for, let's call it, the nerdy people or the researchers? What do you think?
Yeah, it's a good question, because obviously different stakeholders would need different user interfaces, and that needs to be, say, customized and adapted for that. So at least that is being discussed. There are some interesting examples of use of augmented reality, virtual reality, immersive visualization that are using gaming engines that at least show very, say, impressive graphical pictures that can be useful for some kind of communication. Obviously, for not everyone, even the policy people basically say that, well, that's nice, and sometimes we need this, but other times we just need data to put in our analysis. But we need to have an architecture that supports multiple different user interfaces and adapt it to different users. So I think we have an approach that will allow for that, but it's just, say, elements of examples so far, and it's still more work to be done.
Yeah, well, I agree that we have more work to be done in BioDT2. The interface is easy to use, so it's for anyone. But as I mentioned, we are in prototype stage, and the models are still being validated, so reliability of the data, of the results, actually, it's still being evaluated. So in that sense, it's usable, but not yet. Not for policy making. Clearly,
I mean, it's the same approach. Even more, I think that it is. We need to educate the user on which are the questions that they can ask with the data that they have, the tools that they have. Otherwise, they can ask questions that are not supported, get an answer, and get confused, right? So it's not that not only that the system is easy to use, but they need to know what they have to. What they are the boundaries of the systems.
Also some interesting experiments now, obviously, with large language models and kind of digital twin GPT. You ask the questions and it will generate both lexical but also visual answers and graphs for journalists, for instance. So that's the area of climate change is something that is of interest in newspapers, but not necessarily with a lot of data scientists. So there has been some experiment of this kind of language-based generation system, both with text and with graphics.
I would like to add one of the examples that we have that I think it's really cool, and it's not for nerdy people at all, but for nature nerdy people, where you have a map and you can say which species you would like to see in a national park, and then you can put your level of fitness, and it will make a plan on where are the places that you should go to try to find your species. So nature nerdy people would like this one. Yeah. Yes. Like me.
So I think with these real-life nice examples of how digital twins can be really used by end users. I think it's time to close the session. So thanks a lot for the interaction, the questions. Hope it was interesting. And if you still have questions, you are welcome to come to us and discuss anything that you still want to. Okay?
Thank you, Javier. Thank you.